Today's lesson is on the theorem of Pythagoras, and the theorem of Pythagoras works with a right-angled triangle. The theorem of Pythagoras states that the square on the hypotenuse is equal to the sum of the squares on the other two sides. So if you had a right-angled triangle, you have squares on two of the sides of the right-angled triangle. If you were to take those squares and put them onto the square on the hypotenuse, they would fit perfectly, because the square on the hypotenuse is equal to the sum of the squares on the other two sides. What you need to know about a right-angled triangle is where or how to identify the hypotenuse. So the hypotenuse is the longest side of the triangle, and the hypotenuse is the side opposite the right angle. If we look at our first example, we have triangle ABC. And in triangle ABC, we have two of the short sides, AB and BC, and we are able to identify our hypotenuse. And our hypotenuse in this question is line AC. And that line is the longest side of the triangle, and AC is also the side opposite the right angle. So that line is the hypotenuse. So I could either talk about it as the hypotenuse, or I could talk about it as line AC. Another thing that we need to know is how else to label our triangle, and we can label our triangle with baby letters. So the line opposite the vertex is the baby letter of the capital letter of the vertex. So if I look at vertex A, the line opposite vertex A, which in this case is BC, could also be known as baby A. If I look at vertex B, the line opposite vertex B, which is AC, could be baby B. And if I look at vertex C, the line opposite vertex C, which in this case is AB, could be baby C. So that means that when I'm talking about the hypotenuse in this particular question, I could talk about it as the hypotenuse, I could talk about it as line capital A, capital C, or I could talk about it as line baby B. So either way, those are the three ways that I could talk about the hypotenuse in this particular question. The theorem of Pythagoras states that the hypotenuse squared is equal to side 1 squared plus side 2 squared. The square on the hypotenuse is equal to the sum of the squares on the other two sides. So if I were to write out my formula, hypotenuse squared, so that is AC squared, is equal to side 1, which is AB squared, plus side 2, which is BC squared. AC is what I'm looking for, so I'm going to keep it as AC squared. That is equal to AB. I'm going to substitute. When I substitute with brackets. So that is 3 squared plus BC, and BC is 4 squared. So now I would be able to work with AC squared. So AC squared is equal to 3 squared, which is 9, plus 4 squared, which is 16. So that means that AC squared is equal to 9 plus 16, which is 25. But I'm not looking for AC squared, I'm looking for AC by itself. So remember, when you're trying to isolate a variable, you're going to perform the opposite operation. So AC is currently being squared, so the opposite of square is square root. So now what we're going to do is we're going to square root both sides of this equation. The square root of AC squared is equal to AC, which is equal to the square root of 25, which is 5, and you just carry down your units, so 5 centimeters. In the next example, we're determining the hypotenuse again. So we are going to start by identifying our hypotenuse. So in this triangle, our hypotenuse is not AC, our hypotenuse is line EG. But the theorem of Pythagoras states that the hypotenuse squared is equal to side 1 squared plus side 2 squared. So the hypotenuse in this case is line EG. So EG squared is equal to side 1 squared, EF squared, plus side 2 squared, which is FG squared. So now EG, I have been given EG as X, so I'm going to substitute it in as an X squared equal to EF, which is 5 squared, plus FG is 12. squared. So I have x squared equal to 5 squared, which is 25, plus 12 squared, which is 144. So I have x squared equal to 25 plus 144, which is 169. But I'm not looking for x squared, I'm looking for x by itself. So that means I'm going to do the opposite of square, which is square root. And I'm going to square root both sides of this equation to keep it balanced. So the square root of x squared is therefore equal to x, which is equal to the square root of 169, which is 13. Carry down your unit, centimeters. Alright, now I'd like you to pause the video quickly to attempt the your turn question. Alright, now that you've attempted the your turn question, here is the answer. So now we have worked with calculating or determining the hypotenuse. Now once you know how to determine the hypotenuse, you're able to determine any of the three sides of that right angled triangle using the theorem of Pythagoras. So we have the hypotenuse and we have two shorter sides of a triangle, and we're able to calculate any of those three sides using the same formula for the theorem of Pythagoras. There are two methods, however, to determine the shorter side or one of the shorter sides of the triangle, and I'm going to show you both methods now. You can then pick which one you prefer to use. The theorem of Pythagoras states that the square on the hypotenuse is equal to the sum of the squares on the other two sides. So using that formula, we're going to do our first example, which is determining one of the other sides. We need to start by determining which side we are determining. So that in this case is side AB. So we want to calculate AB. Now the theorem of Pythagoras states that the square on the hypotenuse is equal to the sum of the squares on the other two sides. So I'm going to do it the exact same way. So the hypotenuse, which in this case is AC squared is equal to side 1, which is AB squared, plus side 2, which is BC squared. So now all I would need to do is substitute the correct value in place of the correct letters. So AC has a value of 10, so that means that 10 squared is equal to AB is what I'm looking for. So AB squared plus BC, and BC's length in this question is 8 squared. 10 squared is 100, and that is equal to AB squared plus 8 squared, which is 64. So now I want to isolate the AB or the AB squared for now. So that means that I'm going to take this positive 64 across the equal sign, or I'm going to subtract 64 from both sides. The 100 is going to stay the same and stay first. The positive 64, when it goes across the equal sign, will now become negative 64, and that will be equal to AB squared. So 100 minus 64 is 36, equal to AB squared. But I'm not looking for AB squared, I'm looking for AB by itself. So that means that I'm going to square root both sides of this equation. The square root of 36 is equal to 6, carry down your units, meters, equal to the square root of AB squared, which is AB. Now there is a shorter method to do this, and I'm going to show you that shorter method in this next example. So if I look at this next example, I am also calculating the other side. I am calculating in this example side BC. For this question, I want to talk to you about the shorter version of the formula, or the version of the formula that's already manipulated for you. Alright, so the shorter version of the formula is, if you're looking for one of the shorter sides of a right angle triangle, the formula will be the shorter side squared is equal to the hypotenuse squared minus the other side squared. So now instead of the first formula where it's the hypotenuse squared equals side 1 squared plus side 2 squared, now you're going to do side 1 or 2 squared is equal to the hypotenuse squared minus whichever other side you have. So we are looking for BC. So that's one of the shorter sides. So we're going to have BC squared is equal to, and the most important thing to realize when we're using this version is that the hypotenuse has to come first. So it will be the hypotenuse, which in this case is AC. So AC squared minus the other shorter side, which in this case is AB squared. So you can see the difference in the formula, and over here now we have a minus, but we have to remember that it has to be the longest side, the hypotenuse first. Alright, so BC in this question they've given to us as x, so x squared is equal to AC, which is 13 squared, minus AB, which is 5 squared. So x squared is equal to 13 squared, which is 169, minus 5 squared, which is 25. So I have x squared equal to 169 minus 25, which is 144. But I'm not looking for x squared, I'm looking for the x by itself. So that means that I'm going to square root the left-hand side and the right-hand side of this equation. So therefore, the square root of x squared is x equal to the square root of 144, which is 12. Carry down your unit, meters. Now that we've done the two worked examples, I'd like you to pause the video and try the Your Turn section. Okay, now that you've paused the video, now that you've attempted this question, here is the answer, and I've given both methods in this solution. I do hope that this video has helped. Remember, the more you do, the better you'll be.